Hello, everyone. Today we are going to be talking about factoring, but we're going to be factoring different types of polynomials today. So before we get going, let's review the first type of factoring that we've learned so far, which is factor the following by finding the GCF. Pause your video now and give numbers 1 and 2 a try. All right, answers are up. On question number 1, you should have got the largest number and or variables that can come out of those guys are just a 3. They all don't have an x, so I can't take that out. So I'm going to divide each of the terms in this polynomial by the GCF. The GCF should go on the outside, and then anything that's remaining is stuff that's going to go back on the inside. Now, these two pieces are the factors of this polynomial. We would say 3 is a factor because it's the greatest common factor. And x squared plus 3x plus 4 is the second factor because when I multiply those back together, we get the original polynomial. My second one on here, my GCF, you should have gotten a negative 20. Remember, anytime we start with a leading negative, that always comes out in our GCF. The largest number that could go into 20 and 60 was 20. And the most number of variables, they each have, this guy has 1p, this guy has 3, which means he definitely has 1. So we take out the number that they both can give. They both can give 1p. So that's what creates our GCF. So if we divide both by negative 20p, you should be left with p squared minus 3 back on the inside. Now today we're kind of taking what we just did to kind of like think about the next level. Because when we factor things, the idea of factoring something completely is not necessarily just where we stop at the GCF. For example, if I'm going to factor the number 50, we do start by finding two numbers that multiply to give me 50. So for example, if we pick any two factors, let's say we choose, for example, 10 times 5. Now this example here, if I just said factor, technically we're in a really good spot right now. But if we say factor the polynomials completely, this wouldn't be considered completely factored. Because something that's completely factored means we break down not just the number itself into its factors, but we want to break up the factors as far as they can go. So like, for example, if I look at 10, there are two smaller numbers that go into 10 that aren't 1 and 10. 10 we can break up into 2 times 5. This 5, the only numbers that really multiply to give me 5 are 1 and 5. So that one doesn't have any more. It would just stay a 5. And what that leaves us with is this guy right here. We want to break up each of the factors into the smallest factors that we can get. And that's why we have this second method today. Now, this method that we're going to learn today, we don't necessarily use on all polynomials, but if you look at the vocab up at the top, we use it anytime we have a quadratic equation. Now, what a quadratic equation is a polynomial of degree 2. Now, remember, guys, when we say degree, the degree of a polynomial is simply just the highest exponent that we have in the problem. So if it's of degree 2, we want to look at so for example, if we look at the one that I have there, x squared, because 2 is the highest exponent, this one would have a degree of 2. And the method that we're going to use to solve to factor these type of quadratics is something called the guess and check method. Now, what the guess and check method kind of stems from is actually from this next section you guys see down here. Let's pause for a moment and let's go back to what we did previously. And let's think about what happens when we multiply two polynomials together. When we multiply polynomials that look like this, we take each of these and every term that's in the first, we distribute to each term that's in the second. So let's think about like what we multiply together. My first thing that we're going to multiply are the first two terms. We would take x times x, and that's going to give me x squared. Then we're going to take x times 5, and we're going to get a positive 5x. But we're not done here because we have another term to distribute. This negative 4 here also has to be distributed to both terms in the second. So if I do negative 4 times x, we're going to get negative 4x. And negative 4 times 5 is going to leave me with negative 20. Now we're not technically done because once we multiply, we always want to go back and combine my like terms. So for example, x squared, I would look for any other x squareds in the problems. We don't have any in here, but we do have a couple of terms with x's. Because this negative 5x on this 4x have the same variable being raised to the same exponent, we can combine them. 5 minus 4 is going to end up being a positive 1x. And then my last number in my negative 20, there's no other numbers here, so that just comes up. And that would become a negative 20. I don't know why it's not writing right now, guys. Hold on. Okay, we're back. So what I would love for you guys to do right now is just take a moment, and that's all I want you to do on these next 3 problems. I want you to multiply each one of these guys, x minus 4 times x minus 5, x plus 4 times x plus 5, and x plus 4 times x minus 5. I want you to multiply those together and see kind of what we're going to get for each of these answers. So pause your video now and give it a shot. All right, this is what you should have gotten. Now, for most of these, you can probably start to see a pattern. When we multiply these together, you're going to notice that all of these polynomials end up being 3 total terms. And they even look kind of similar. The main thing that's kind of difference between all of these is the number that's in the middle. The number that's in the middle, and then the number that's on the end. And let's think about why that is. When we multiply things together, in order to turn, for example, the one that we did into this, we had to multiply 4 total things together. We did the first terms together first, x times x. That's what got me the x squared. But then we did our numbers. If I did negative 4 times positive 5, that's what got me this number on the end. So when we look down below here, but then if you looked at the middle terms, here's where we multiplied the middle guys together, and that's what got us this middle term. So when we're going to work our way back and factor this, we're going to use exactly that process to kind of work our way backwards. For example, this polynomial here is a degree 2 polynomial. We have a number that's being squared, an x term in the middle, and a number that's on the end. And what that means for us is that this potentially factored into 2 different polynomials. And we want to think about where those numbers came from. Whatever went in this spot right here, look at what happens when we got this x squared. Well, how did we get that? We took the first 2 terms together and multiplied them together. And that is what told me what's going to go in the first blanks inside those parentheses. So I know for a fact on this one, x times x have to be what goes in that first spot. Now, in all of the other answers, one thing that we know here is that my numbers affect both the middle term and the number that's on the end. We took these guys first and foremost. Let's think about the guy that's a little bit easier, the guy that didn't have any like terms. Well, how did we get, I didn't mean to do that. How did we get negative 20 here? Well, we took the numbers that came second in that polynomial. So in mine down here, whatever's going to go in this spot and this spot have to be things that multiplied to give me a positive 12. Now here's where we have some decisions to make, because there aren't just one set of numbers that multiplied to give me 12. If we list out some factors of 12, we could do 1 and 12, 2 and 6, 3 and 4, and those are my only factors of 12. So the question kind of becomes, how do I know which numbers are going to go in that spot? Well, that's not the only requirement. I know that what goes in those red blanks have to be one of those pairs of numbers. But if you'll notice up here, for example, those numbers also became numbers that affected what my middle term was. So when we look at these, we have to kind of think about which ones will actually work. And that's why this method overall is called the guess and check method. We're going to try some of these and see which ones add to give me a 7x. So let's try my first ordered pair, or excuse me, my first factor pair. Let's try 1 and -12. So if I try a +1 and a +12, let's see what that's going to be for us. If we multiply all that piece out, now there's a couple of ways that we can do this. Sometimes for the guess and the check method, I know I have 2 boxes here for that. We're just going to do it in the same boat because I already kind of know what some of these are. I know that if I take x times x, we get x squared. If I take 1 times 12, we get a +12. So far, those pieces of my polynomial are great. The things that I can't see, though, are the middle terms, because the middle terms are what we end up having to combine. So let's see what we get. If I take 1 times x, we're going to get a +1x. If I take x times 12, we're going to get a +12x. But if I add those guys together, just like we did up here, right? We added our middle terms together. You're going to notice, though, that we have kind of an issue here. That means if I do 1x plus 12x, we get 13x. Does that match what's in the middle here? No, it does not. So what that tells me then is that this polynomial can't be my final answer. And we move on to the next pair. Now, some students can probably say to themselves, well, Ms. Hardy, I kind of can see what's going to happen here. If I know that x times x has to be in here, right? Well, my 1 times 12 over here, this didn't work. So let's try another set of numbers. Let's try, for example, 4 times, oh, and I don't know why that's happening. Let's try my factor pair of 4 and 3. Let's try a +4 and a +3. Well, here, look what happens. If I do 4 times x, we're going to get 4x. X times 3 is going to be a +3x. And if I add those guys together, we get the middle term of 7x. What that tells me then is that this is going to be my final factored form. That's what this guy breaks down into. Those are the 2 polynomials that we multiplied together originally to get that guy. So when we work through each of our polynomials, that's essentially how we're going to start. We start by saying, okay, I'm going to pick my polynomials here. Because I have a degree 2 polynomial, that means I had to have 4 terms inside that polynomial. Now, what goes in the first blank has to be what multiplies to give me x squared. And the only thing that gives me x squared is x times x. Now, what goes in these second blanks here, right? That has to be things that multiplied to give me 2. Well, 2 is kind of nice in that there's really only 2 options. The only factors of 2 are 1 and 2. So let's try it out. If I do x plus 2 and x plus 1, let's check to see if this works. If I do 2 times x, we get 2x. X times 1, we get 1x. And if I add those together, we get 3x. Now, is that the middle term of our polynomial? Yes, it totally is. So this is my final factored form. So what I want you guys to do is I want you guys to try these next 2 on your own. I want you guys to try C and D. Pause your video now and give them a shot. All right, let's check these out. Now for my first one up here for part C, we are looking for numbers essentially that multiply to give me 16, that add to give me -10. Now this is part of where the guess and check kind of comes from. Because if I'm looking for numbers that multiply to be 16, these are the numbers that you should have gotten. But not all of those can really even get me close to 10. 1 times 16, or even if I change signs. Now, if it's a positive, that just means my sign has to be the same. So my numbers could either be +1 and +16, which would add to give me a +17. Or it could be -1 and -16, which would get me to -17. Either way, though, that doesn't get me to -10. So it can't be 1 and 16. Now 2 and 8, I'm liking. If I take 2 times 8, I do get 16. But the problem is if I do positive 2 and positive 8, I get a positive 10. And that doesn't help me here. I'm looking for numbers that give me a negative 10. And the only way we can do that is if we make both these signs negative. Negative 2 times negative 8 is still positive 16, but negative 2 plus negative 8 gives me negative 10. And here's where that kind of check comes in. If we check this out, if I do negative 2 times x, we get negative 2x. X times negative 8 is going to be a negative 8x. And adding those together, we do get the middle term that you see here. And what that tells me is this is my final factored form. Now, if they don't turn out to be the same, then we cross it off and we just try one of the other pairs. So like, for example, on this next one, if you weren't sure what your answers are, let's start with some that just could even get me around 5. All of these numbers already multiply to give me 24. We can say like 1 and 24, for example, those don't multiply to give me 5, or excuse me, add to give me 5. So no way, shape, or form can that be it. Now 2 and 12, let's say you weren't sure. Here's the beauty of this. If I check my answer, now if I'm going to guess signs on this one, a negative 24 means I have to have 1 positive and 1 negative. So let's say just for fun, I try this combination here. Now I'm already kind of suspicious because negative 2 plus 12 gets me negative 10. So definitely can't be that one. But if I try some of these out, the one that even really, the one that comes close is going to be 3 and 8. Now signs wise, and again, if you're not sure with signs, let's try it out and let's see what happens. If I try doing a positive 3 and a negative 8, let's see where that gets me. That's going to get me a 3x and then a negative 8x. If I multiply, now let's add them together. 3 minus 8 is going to be a negative 5x. And actually that one works beautifully. That's the number that we see in the middle. So that would be my final answer. All right, guys, this is part 1 of our factoring video. Please move on if you want to start working on the part 2 of our factoring.